start with the very first sorting algorithm called bubble sort here. So let's recall about sorting. So what is sorting first of all? Sorting means to arrange elements in an array in a proper manner. What do you mean by proper means? Either ascending or descending manner. Okay. So sorting means we have to arrange. The arrangement can be ascending or descending. Okay, so let's focus on ascending. We will do sorting in ascending. Generally, it is from low to high. Okay, the arrangement should be from low to high. So let's say we have a given sample array. So array is like this. What do we have in array? 44, 55, 33, 88, 77. Then we have 22, 11 and 66. Now considering this array, let's apply bubble sort on it and the final answer must be like this. 11, 22, then we have 33, 44, 55, 66, 77, 80. Now this must be our answer, final answer after, after we apply bubble sort. Okay, after we apply bubble sort, this should be our final answer. So how to do that? So let's apply bubble sort in this array. Okay. So in bubble sort, the technique is as such that we have to scan this, array multiple times, and in each scan, what happens is that the highest element is placed at the last. Okay. So let's say in scan number 1, the highest element 18 is in its correct position, that is it is in the last position. In scan 2, the second last element, that is 77, is in its correct position. Similarly, in scan 3, the next element, that is 66, comes to its original position, that is third from the last. Okay, this way it happens. How it happens? Let's check. Okay, so first we will consider on pass 1. Pass 1 means in first scan 88 must be in its correct location. So what happens in each scan is elements, side by side elements are compared, and whenever a conflicting pair comes, we just swap it. So what do you mean by conflicting pair? Conflicting pair is a pair in which A comes before B and the value of A is greater than B. This is a conflicting pair. Example, suppose 55 and 88. This is a conflicting pair. You may say, why ma'am? Because 88 has greater value. So it should come after 55, but it is coming before 55. That's why it is a conflicting pair. Okay. So such pairs are called conflicting pairs. And in each pass, we resolve this conflicting pair by swapping them. Okay. While we scan in each pass, we simply see if there is a conflicting pair, we simply exchange it. Okay. We simply exchange all the conflicting pair coming in the way. Okay. So let's see how the scan takes place. In a scanning, first of all, 0, 1, 2, 3, 4, 5, 6, 7. We gave the indices. 0 is checked with 1. Okay. 0 and 1 are checked. 44, 55. Is it a conflicting pair? No. Done. Then 1 and 2 is checked. Index 1 is checked with index 2. 55, 33. Is it a conflicting pair? Yes, it is a conflicting pair. So we need to swap it. So we will swap it and we will change it to, this is 33, this is 55. Okay, I hope you got it. Now again, then 2 and 3 is checked. 2, 3, 55, 88. Is it conflicting? No, it's fine. Then 3 and 4. 88, 77. Is it conflicting? Yes, it is conflicting. 77 must come before than 88. So 77, this is 88. Okay. Again you have to check. 4 and 5 now. Side by side pairs. 88, 22. Is it conflicting? Yes, it is conflicting. So again we have to swap. What do you have to do? In place of 88, 22. And in case of 22, you have to simply write 88. Again, go on. 5 and 6 is checked. 88, 11. Is it conflicting pair? Yes, it is. 11 said at the end of pass 1, what is the result? 77, 22, 11, 66, 80. So here, as you can see, at the end of pass 1, the highest element is at its correct position, isn't it? At the end of pass 1 result. At the end of pass 1, 88 comes to its correct position. Okay. Similarly, in the next pass, that is pass 2, we will scan up to what? This is at its correct position. We will scan up till this index, that is 0, 1, 2, 3, 4, 5, 6, 7. We did not check. Up to 6 you have to check. Okay, after 6 you will again conduct a scan in a similar manner as this. And as you scan one by one, side by side, two elements, simply check if these are conflicting pair. If it is a conflicting pair, swap it. Okay, along the way, whenever you find a conflicting pair, just swap the conflicting pair, and in the end what you will see is you will get a sorted array. So let's continue with pass 2. If we continue with pass 2, let's I'm directly doing it. I hope you are getting the drill. 44, 33 is swap, isn't it? Because 44 must be after. So this is a conflicting pair, so let's swap it. 33, 44. Again 44, 55, it's fine. 55, 77, it's a swap. 55, 77 is okay. Pardon me. 55, 77 is okay. Okay. Now 77, 22, it is not okay. 22 must come first. 22, 77. 77, 11, again. 11 must come first, 77 must come. 66, 77, again 66 must come first, 77. So in the second pass we see 77, which is the second largest element, is at its correct location. Again pass 3, this was pass 2. In pass 3, let's do it. 33, 44, this is the result of pass 2. Now again, let's check. 33, 44, fine. 44, 55, fine. 55, 22, not cool. We have to change it. So what will happen? 22 comes here, 55 comes here. 55, 11, not cool. 11 comes here, 55 comes here. 55, 66, fine. 66, up to 66 we have to check in pass 3, isn't it? So now we got the result. Now again pass 4. Let's check what happens in pass 4 again. 33, 44, result of pass 3 I am writing. So we have to check until this. 33, 44 fine, 44, 22 not fine, 22 must come here, 44 must come here. 44, 11 not cool, 11 here, 44 here, 44, 55, okay. So this is the result. Then pass 4 again. Sorry, pass 5. Result of pass 4 I am writing, then we will apply pass 5. So 66, 77, 88. Okay. I am just rubbing off the unnecessary stuff. We should get a sorted array in there. That is I. Isn't it? 11. So now apply pass 5. Until what we have to apply? We have to apply in this. 33, 22, not cool. Just change 33. 33, 11, not cool. It will change 22, 11, 33, 44. 33, 44, fine. So pass 5 result is this. So what is pass 5 result? This is pass 5 result. Again pass 6. Continue pass 6. In pass 6 what happens? Let's apply 22, 11, not cool. What will come? 11 here, 22 here. 22, 33, fine. 33, 44, fine. 44, 55. So we have to check until 33. Fine. 11, 22, 33, 44, 55, 66, 77, 88. And how long you have to, do this? Until pass 6. Okay? pass minus 1. So this is our sorted array. We have come in the pass 6. So maximum passes needed is generally 7. So what is our n minus pass minus 1? We have to continue till n minus passes n minus 1. Sorry. So we have to continue till maximum number of passes is maximum number of passes. Here we got the answer in pass 6, but maximum number of passes is 7. That is n minus 1. N minus 1 passes needed. Number of passes needed is n minus 1. Okay. So if we write the code, here we have two loops. Okay. So we got the answer. I am just writing the code for you. I will share the code separately. I have already shared the code separately actually. I have given the notes for DS. Please go through it. You will find the code there. So for your, understanding, I am just writing the code. That is what do we need. We have to have passes. Passes starting from 0. Pass less than n minus 1. Pass plus plus. Okay. And in each pass, what are we doing? We are starting from 0 and going till how much? To the end, depending upon where we are. If it is a first pass, if the pass is 0, we have to go till the end. If the pass is 1, we have to go till second last. So it will start from for I is equal to 0, I less than n minus pass minus 1. Okay, n minus pass minus 1, I plus plus. Okay, then we have to check if ARR, which is the array name, okay, if ARRI is greater than ARRI minus 1, okay, then what we have to do? Simply swap. Swap means you know the swap code, right? You have to take a temporary variable temp is equal to AI is equal to AI plus I minus 1, sorry. Then AI minus 1 equal to 10. So this is your swapping method. Okay. So when I is equal to 0, sorry, when pass equal to 0, we have to go till n. Why? Because n minus 0 minus 1 means, what is n minus 0 minus 1? So it is simply n minus 0 minus 1 means n minus 1. Okay. N minus 0 minus 1 means n minus 1. We have to go till n minus 1. That is 0 to 7. Okay. When pass is 1, we have to go from n minus 1 minus 1. That is n minus 2. We have to go. That is n minus 2 means second last up to 0 to 6. Okay. I think it is complying with the code we did. With the way we did. Okay. So this is your bubble sort. Okay. So I will just write void bubble, the function name bubble sort. And what are the input you have to take in the sort? The array, integer ARR, okay, and int n, okay, which is the size. So this is the input. Then you have to take an integer temp, okay, temp, pass, and I. I hope you are sorted now. Yeah, fine. This is the function close bracket. So this is about your bubble sort. Okay. So I need to understand the code for bubble sort. But in the next one, that is the selection sort and insertion sort, we won't go through the code. Okay. I will simply make you understand. You have the code in place in your notes. You can go through it. And if you have any doubt, we can discuss in the Zoom class. But in the class, let's first understand the idea of all the sorting algorithms. Okay, idea is more important. If you have the idea, you can generate the code by yourself. Okay, if I am making you understand the code, it is just a matter of 2 minutes, 3 minutes, which you have already. You should put your brains into it on your own and try to grasp the concept that whatever madam made us study, let's check out the code for that. Am I able to understand? If you are, then well and fine. If you aren't, then please, questions are welcome from your side in the Zoom class. Okay? So let's check out the selection sort. Okay? Let's check out the selection sort. So taking the same example of the same code, 44, 55, 33, 88, 77, 22, 11, 6, 66. Okay, let's take this example. Now, what selection sort does is, selection sort try to select the highest element and put it in its original position by exchanging with the element. Okay, so here it selects the highest element and put it in its right position. What is the highest element? 88. Okay, so 88 is supposed to be in the last place. Okay, so what will happen is 44, 55, 33, 88 and 66 will be exchanged. 66, 77, 22, 11, 88. Now again, in this resultant array, what will happen? Again, selection sort will, find the largest element up to this. Earlier, it found the largest element up to this, and it exchanged it. In this case, it will find the largest element up to this, and it will exchange. So, what is the largest element? The algorithm for finding largest element is very easy. You can check it out. How to find the maximum in an array. So that's what it does here. It finds the maximum up to this and then it replaces it with the last element of that. Okay. So here the highest is 77. So 77 and 11 are replaced. So what is the answer now? 11, 22, 77. Now up to this again the process follows. Up to this again it finds the, so these are sorted basically. Up to this it is sorted. Now we are applying selection sort on this. Again, what is the largest element? 66. So 66 and 22 will be exchanged. So what will be the answer? 22, 11, 66. Up to this it is sorted. 77, 88. Sorted. Now again we have to find the largest among this. What is 55 and 11 will be exchanged. So 55 and 11 will be exchanged. Then what will be the result? 55. Now to this it is sorted. Again we have to find the largest element, which is 44 and 22 will be exchanged, and the answer will be 22, 11, 33 and 44 से sorted हो जाएगा. Again 22, 11, 33 में क्या होगा? Largest 33 है, which is at its correct position, no problem. Then 22, 11 will be taken and these things will be sorted. 22, 11, 11, 22. Then 33. So next the resultant is, very simple. It's done. 7, 8, 8. So this is our sorted array. So selection sort, what it does is very simple. First of all, it finds the largest among the entire array and then it swaps it with the correct position element. Okay. Then again, once the largest element is in its place, up to the second largest element, the array is unsorted and up to this it is sorted. So what it will do? It will repeat the same process. It will try to find the largest element and it will swap it with the correct position element. Then after which this is sorted. So until it is not sorted, again it will repeat the same process. Okay. So selection sort basically finds the largest element, selects the largest element and it puts it in its correct position. Okay. By exchanging with the element which is already in the correct position. Okay. So it simply exchanges. Then again it repeats the same process of finding the largest element and again putting it in the same place. Okay. This way, one by one, it sorts it puts the element remain in its correct place. This is how selection sort works. And its time complexity in best cases order of n and most cases order of n square. So time complexity, please remember, in bubble sort, time complexity is always order of n square. Okay. In selection sort, time complexity in best cases order of n and its worst cases order of n square. Okay. When the selection sort happens, best case happens when it is already sorted. You do not need to, you will find that it is already sorted. So you don't need to, there is no point of exchanging. When there is no point of exchanging, in just one pass you will get to know that it is sorted. Similarly, in bubble sort also, you will get to know it is sorted. So in best case it is order of n and in worst case it is order of n square. So same case for both the sorting algorithm. Then in best case you have order of n and in worst case you have order of n square. In the next class we will try to understand insertion sort and merge sort. Merge sort is really important algorithm. I need your complete focus in that. And after that we will understand quick sort and file handling we will take it up in Zoom.